Hello everyone, I'm Jian, a postdoc from Penn State. Today I'm here to present our work about how to use virtual reality to facilitate place-based education. This project is a collaboration between the Center for Immersive Experiences at Penn State and the US Forest Service. I want to start with the big picture. For me, place-based learning is using the environment as the tool for learning. Students have the opportunity to learn from interacting with raw materials, which can not only reinforce knowledge acquired in the classroom or from textbook, but also allow them to gain an experiential understanding of the topic. The current study focused on the Stanislaus Tuolumne experimental forest in California. Such a forest provides students with a spatial and contextual way of learning wildfire processes and impacts of management strategies. However, learning in a real-world place can present many challenges, such as safety concerns and financial issues. This is especially relevant to the context of COVID-19 pandemic, during which higher education institutes have to suspend most of the field-based activities to ensure social distancing. But even without the pandemic, it is still very impossible to send our students to the Stanislaus Forest, because they will have to travel from the east to the west coast of the United States. So travel distance, along with seasonal limitations, limit the potential of using this site for active learning and engagement. In light of these logistical challenges, we developed a digital version of the place-based tour to the Stanislaus Forest. Such virtual tours allow students to observe and understand ecological phenomena in the classroom or at home without the need to go outside.
Welcome to the Stanislaus Tuolumne Experimental Forest.
Next, I will briefly discuss the design choices we made for the Stanislaus virtual tour. The overall goal is to make our virtual tour application as scalable and accessible as possible in the context of pandemic. Although immersive VR is attractive to students, the use of VR headsets is still uncommon for real education, and is largely limited to the physical lab space. In our study, the virtual tour was originally created as an immersive application for standalone HMDs such as the Oculus Go and Quest. However, for the purpose of this study with students taking classes online during the pandemic, we created a WebGL adaptation of the tool that students could run in the browser on their personal computers. To maximize the benefits of place-based learning, we need to think about how to use VR to deliver a high-fidelity forest environment. Creating tools consisting of 3D models allows for free movement in the scenes, but it is a quite demanding process, especially for natural landscapes. In contrast, it is much more straightforward to create a highly realistic virtual tour based on 360-degree images. All you need is an affordable 360-degree camera. With this approach, it is possible for course instructors to become content authors. So, 360-degree imagery seems to be the most suitable approach for applications in education on a broader scale. During the tour, different media resources such as maps, photographs, and forest stand visualizations are overlaid on top of the 360-degree images to complement the narration. In addition to the normal ground view, students can also access the elevated perspective in the same location so that they can get a better understanding of the forest features. In some locations, we also provide students with drone images that allow them to access a large-scale aerial view of the forest landscape. Finally, we need to consider to what extent students should be able to explore and interact with the virtual tour. In this study, students were passively teleported through a sequence of 360-degree images, in which the student can freely look around, while listening to expert audio narrations explaining what's going on in the scene. We chose the passive approach because of its advantages, including no training or instructions needed, low development costs, and focus on observing, but investigating how this approach is received is part of the study. Because there are very few empirical studies to guide the design of such virtual experiences of real-world research site for place-based education, we first of all wanted to assess students' overall acceptance and perception of the virtual tour in the classroom on a larger scale. Second, we became interested in how individual differences impact learning in a virtual tour. We therefore looked at how gender and familiarity with the topic of the tour as two user characteristics that could potentially modulate students' learning experience. In total, 121 undergraduate students were recruited from geography and forest ecology classes at Penn State. In the pre-questionnaire, we asked participants to report their demographic information such as gender and age, as well as their level of familiarity with the topic of forest and fire management. The post-questionnaire consisted of a series of measures to assess different aspects of learning experiences. Most of the question groups in the post-tour survey were adopted from this literature. Overall, the responses to most of the questions on learning experience show a very positive evaluation of the learning of the virtual tour in the context of undergraduate ecology learning. This indicates that the majority of students have a positive attitude towards more usage of this kind of virtual applications as part of their university education. In line with this, most students indicated in the open-ended question that the current method of instruction have advantages over classical methods of teaching used in traditional classrooms. To assess the impacts of previous knowledge of the topic on learning experience, we split participants into low and high familiarity groups. There were no group differences for any of the question categories. Both high and low familiarity students seem to assess their learning experience in an equally positive manner. Next, we investigated the effect of gender on learning experience. We are a bit surprised to find that female students reported significantly higher learning experience, overall satisfaction, and improved understanding than male students. While we don't think that the data collected is conclusive, the open-ended responses suggest a higher level of appreciation by females for the visual features, level of immersion, and the actual content of the tour. One explanation could be that male students have higher demands when it comes to technical aspects of the application, while for female students, there is a stronger novelty factor and a tendency to be more concerned with the course content itself. So, take-home message. While the beauty of fully immersive virtual tours for place-based education has been well demonstrated in literature, we cannot expect that every student has access to a VR headset. It is therefore important to gain an understanding of how current technology can be appropriately applied within financial and technical constraints. The results indicate that students not only assessed the browser-based virtual tour as a positive experience with the potential to improve learning, but they also rated the experience as realistic and immersive. A standard laptop or desktop computer, together with low-cost 360-degree images, seems to be enough to fulfill the needs for learning ecological principles and concepts. However, different learners may benefit differentially from the VR experience. Our results revealed surprisingly strong differences between male and female students in virtual environments. Further investigations needed to better understand this and identify other characteristics that make some learners more receptive to VR learning than others. Thank you. If you have any questions about this work, or if you would like to know more, please contact the corresponding author, Jan Oliver Walgren, at juw30@psu.edu.